For taking this session. Last time we talked about the sigma notation, the expression and expansion something. But now this time we have go deep into the sigma notation property and the rules. Let's start the one by one. Okay, so let's see the first one. First one is C here is constant. Okay, is constant, and start from I until n. So what's the result? Please remember this also formula, okay? I'm saying this result, but please remember because it's always happen, right? So this result is n times c. You say if you ask you why, that will be easy, right? Because there will be start from I equals to 1 will be c, and then sec I equals to 2 will be c, until the nc, right? So totally is n, right? So nc. How about here? I start from m. Let me directly answer you first. Okay, so this is equals to what? N minus m plus 1 times c. Why? I now use another way. I just give you an example of if this is 4, if this I start as 2, and this is still c. So what it looks like? So start from 2, right? C, and then start from 3, then start from 4. So 3c. If 3c based on formula is 4 minus 1 plus 4 minus 2, I equals 2 plus 1, right? C, so equals 3c. So you can see this is right? So this is based on the constant number. How about this one? Here you can see here is it's a constant number together with the expression or function, right? So let's be first write to you the result. The result is we can move c in front. So n I equals 1 and fx. Why? Let's compare it easy. Just to give example, this one can be written as cf1, right? And then cf2, right? Until cf what? N, right? Or xn, that may be much easier. x1, x2, xn. Then of course the common factor is c, so it can be like this way. Okay. So what is interpretation about this? If they have the sigma notation, they have a constant within the expression, you can draw the constant outside. Let's see the next one. It's a summation of the two function and in the sigma notation. So it's directly I will write you the result. The result is separate them. X equals to 1, then fx, then plus sigma x equals to 1 and gx. This one will be easy. You can be the one to doing that. Okay, so how to interpretation about that? So summation of the two function, their sigma notation can be separate with each other. Okay, how about this one? In fact, that we learned that before, right? We learned that before. The result should be what? The result should be like, right? Why we do like this way? Please remember this is a formula, okay? So why we do like this way? How come? Because as we do like this way, 1 plus n and 2 plus n minus 1, and like this way, right? So 1 plus n is n plus 1, 2 plus n minus 1 still n plus 1, right? How many this kind of summation? of course, they have totally n divided by 2. So this is exactly like this way. Okay. So if I give example, I ask you the summation from 1, 2, and 10. How to do that? It's quite easy, right? So this should be 10. So it should be what? 10 times what? 11 divided by 2, right? So this will be looks like 55. Quite easy, right? Okay. Then let's come to a very, very important concept. Telescope. Telescope in sum. Don't ask me why it's called telescope in sum. I don't have idea. Okay. I think the one who deduced this, who made this, they give this name. Okay. Uh, telescope in sum are, let's directly just looking on the formula. This is based on the sequence function, right? The same function, but based on the sequence, the first and the second, or the just linking together, right? A plus 1 to A, or A minus 1. So if they are sequence subtraction, when they start from m until n of the sigma notation, their result will be quite easy, just equals to fm plus 1 minus fm. How it will be looks like this, because it's a companion easy, because they can cancel, right? Just to give example, just we based on this one, we write in like a we first like a f, right? I start from m, right? I start from m, so m plus 1 minus m, right? And then plus what? M plus 2 minus m plus 1, right? So it's cancel until what is left? Until what is only when m plus 1 minus m, right? So to prove this is quite easy, but this telescoping sum is very, very useful, especially they use for deduce some other function or summation of the sigma notation. Okay, let's solve this one. I think this is not solved. This is just a impression of another formula. Another formula. This formula is how to like write in I square summation of the sigma from 1 until 10. So let's write it in this way. This is looks like, just give example if 10 is to n, because it can be anything, right? It can be 11, right? So this is looks like what? I square is equal to what? n plus 1, based on this one, 2n plus 1 divided by 6. So this is these summations, this sigma notation is quite useful, because give example, because based on I square, give example, if it is like a how to say that, if based on the if I just example 1 square plus 2 square plus 7 square, if you're doing that, it's quite hard, right? Right? But right now it's very easy. Here you can see that 7 and 7 times 8 times 2 7 is 14, 15 divided by 6. So this is right, very easy. And this will be like 5, right? And this will be 4, right? So it is 20, 140. Just that easy. Am I right? So how to deduce this function or summation of the series? You can do it through by what I just talked about, that the important one, telescoping sum. I will not spend time to do this. There are other materials you can learn through online. Okay, so let's go to one example. Let me see how many examples do I have. Okay, I have 2 examples. Very good. So how to do this based on what we learned. So first we observe they have 3t, right? Coefficient we can move outside. Plus we can separate. So right. So we can write in as what? Sigma 10 I equals to 1. 3 can draw out. So this can be I. Then this just because the what? 10 I equals to 1 and the 6. And then this will be looks like what? Based on the first one, 1 to 10, right? So this we learned that formula, right, is 2 over what? n plus 1, right? N is 10. 10 plus 1 is 11. And don't forget they have a 3 here, right? So plus, and then this is what? Second one is what? This is the constant, right? Constant, we have formula should be 10 times what? 6, right? So that's easy. So here is we get what? We get 5. 15 times 11, right? Times 11. 11 times 15. 15. It's not that easy. So 55 times 3. Yeah, then this would be easy. Plus 60. So it would be 225. Okay. Let's see the last example. This example exactly is what we talk about telescoping, right? So how can we simplify this one? So it looks like same, huh? I equals to 1, and then I plus 1 minus 2 over I. Look at here, I plus 1 minus I, am I right? 2 we can draw in front, right? So sigma 10 I equals to 1. So this can be I plus 1, right? It's negative 1 minus I negative 1. Am I right? Am I right? Right? So this we can take into the formula. The formula will be take the 10 directly, right? So 2 times what? 10, 11, right? Minus 1. So this definitely will be a negative number. Negative number, right? So this 1 over 11 minus 1 is negative 10 over 11. So it will be negative 20 over 11. So we got it. Okay. So these are all the properties and rules of the uh, sigma notation, as well as the most important concept that we just discussed about the telescoping, right? Yeah, telescoping. Okay. So telescoping sum. So thank you very much to join this session. Thank you. Have a nice day. Bye-bye.